session, we will see how to use the ntop suite to analyze an incident. So if we have an attack affecting our network, we want to analyze this issue and check what's going on, who is behind this, and in this specific case, we will see data exfiltration case. We will see how to see what data is exfiltrated out. So in essence, we go through a few steps. We will select an incident case, so an example of an attack. We will analyze a typical corporate network architecture and see where to put our, let's say, sensors to analyze the traffic and detect issues. We will see how to configure the software and how to get notified when there is an attack and how to analyze this attack. So in this training, we will see almost all the tools of the ntop suite and even third-party tools like Suricata, which is an IDS. So we will see ntopng, which is our web-based traffic analyzer, which is both a collector for flow data or a tool that you can run standalone, analyzing traffic from a network interface. We will see nProbe, which is our sensor that can be used in combination to ntopng. Thank you. In combination with ntopng, that can collect net flow from routers and switches, or again analyze traffic from a mirror or spam port or a tap. And we will see also nProbe agent, which is an agent that you can install in all the hosts in your network to extract more information. Also, for instance, the process that generated some traffic or the user that is running the process. We will see ntodisk, which is our network to disk, so our continuous traffic recorder, able to dump pickup data, so traffic in all format packets to disk in pickup format. We will also see the new feature that we introduced a few weeks ago, a few months ago, which is the smart recording. We will see later what it is, but also tomorrow we will talk about that at the conference. Suricata is the IDS, the intrusion detection system, which is a tool which is specifically designed for detecting stuff like malwares, and it's based on signatures. Later today, we will have our friends from Emerging Threats. They write signatures for Suricata, so we will see in detail how it works. We will also use Wireshark. I don't know how many of you use Wireshark. So it's usually a well-known tool which is used to analyze pickup files. So if we record some pickup data with ntodisk, we can analyze it with Wireshark. And in order to configure all the tools, we will use our new nBox user interface, which is the user interface web-based that we usually install in our appliances. And of course, there are other components which are part of our tools because they are libraries. In this case, we have nDPI, which is the deep packet inspection framework used by ntopng and nProbe to detect the application protocol behind a specific network communication. And also pfring, which is our packet capture framework, which is used by our application to capture traffic at high speed during commodity hardware. So we will see all those components in a single, using a single example. So I was looking for an example for today to show you how to use the tools. And I selected the data exfiltration case. So in this case, we have our private network, which is connected to the internet through a firewall, a proxy that does content filtering, for instance, to avoid that to avoid unwanted communications, to avoid that some data from our network is exfiltrating through internet. And then we have the internet. So in the data exfiltration, we usually have a host which is compromised. Maybe there is a malware running, or a host which is accessed in some way from an attacker, even with some injection to a web server, which is sending confidential data, private data, out of our network. So this is the generic definition of the text filtration. Now I have to select a specific case to demonstrate you how to use the tools to detect this kind of issues. And I selected DNS, data filtration over DNS. Why DNS? Because it's a simple protocol and it's usually allowed by our firewalls, for instance, and it's usually not inspected. So it's commonly used as a vector for many attacks, including channeling or the data filtration. Here I'm mentioning a couple of tools just as example that you can use for doing tunneling over DNS, DNS cut, or the text filtration. This is the tool that we will use today. So in practice, what happens with DNS, this is just one of the let's say techniques that you can have for exfiltrating data over DNS. You have a compromised host which is doing a DNS request to an external server, even through our local DNS resolver. And here we have, for instance, a DNS query, type A, for instance, where some data is encoded into the subdomain. So when we do a request like this, our local DNS server will forward this request to the authoritative DNS server to resolve this name. And doing this host is exporting some information which is encoded into the request. So for instance, we have a file, this is compressed or something, encoded using base64, for instance, and exported to the DNS server, which is driven by the attacker. Is it all clear? Now let's take a look at a typical corporate deployment architecture, let's say corporate network architecture. So we usually have our internal network, then we have some switches, like here we have a core switch, a firewall, our router, internet router, and the internet. Now let's see how to deploy the software to monitor this network. So at least we need ntopng, which is our web-based traffic analyzer. ntopng can process both traffic so a copy of the traffic, raw packets, from a mirror port, or a spam port, or a tab. So we usually take a mirror port from the core switch, and we connect it to ntopng, and we start analyzing this data. Or you can use ntopng in combination with a NetFlow exporter. That can be a router or can be nProbe. So nProbe is a probe, a sensor that can process traffic, packets from a mirror port or NetFlow from a router and send traffic information to ntopng. So we say that nProbe exports flows because it doesn't export real traffic, it exports just a summary of the traffic, which is all the network communications with metadata. So IP, source and destination IP and port, packets, bytes, ASL protocol, and additional metadata. Why you need nProbe? Usually you need nProbe because you have a large network with many, switches where you want to monitor the traffic, or if you have traffic at high speed, especially at 100 gigabit, you probably need nProbe CentOS, which is the fastest version of nProbe. So in case you have a distributed network, even with many locations geographically distributed, you can process the traffic and export a summary of the traffic to a single centralized ntopng. Then we have the nProbe agents. So this is nProbe, but in this case we run this on all the hosts in our network. And rather than running this on a single point, which is the core switch. The advantage of this, of course, the disadvantage is that you have to install this on all the hosts. But the advantage of this is that here we have visibility also on the processes running on the hosts. So we can export not just the network communications and metadata, but also other information like the process, which is generating a specific network communication, and the user that is running this process, which is really useful when analyzing security threat, for instance. And then we probably want also to run ntopdisk in our network. Why we need this? Because if we are good with traffic information like network communications and metadata, then we don't need it. But if we want to, when analyzing troubleshooting or analyzing a network issue, we want to really drill down up to the packet level and analyze the traffic with Wireshark, we need the pickup files, pickup data. So in this case, we need ntopdisk. So ntopdisk is recording everything, raw packets to disk. We usually have, at 10 gigabits, you need an array of disks. We will see later, or even tomorrow, what are the requirements, especially in terms of disk space for running ntopdisk. So you can run ntopdisk, which is recording everything continuously, like a security camera. And you can use it in combination with ntopng. So in ntopng, we will see that from the user interface, you can select, for instance, a specific time interval, apply a filter, like wanted traffic for a specific cost, and download the pickup data for that time interval and host from the user interface. And then analyze it with Wireshark, for instance. It's also common practice to deploy an IDS also for detecting malwares or security threats. Suricata is an example, which is the most common today, but there is also Snort, which is also based on signatures, as I said before. But there is also Zig, which works in a different way. So you have multiple choices. Suricata can be deployed also on a mirror port on a switch, for instance, to analyze all the traffic and exports events. So as soon as it detects an anomalous flow, for instance, a security threat, a malware, it exports an alert that can be ingested by ntopng. It can be used to augment the data which is already extracted from the traffic by ntopng or nProbe. So this is the final deployment with all the tools in our network. This is an example. So this is a possible deployment. As I said, you can have ntopdisk without, ntopng without the probes, or you can have ntopng without ntopdisk. There are many combinations, but this is what I selected for the demo today. So here we have our switch, which is sending a copy of the traffic to ntopdisk and Suricata. ntopng can extract pickup files, pickup data from ntopdisk. Suricata is exporting alerts as soon as something is detected on the network to ntopng. And ntopng is connected to the probes, which are exporting traffic information, including processes and users, to ntopng. Is it all clear? Okay, so let's see how to configure the software in order to achieve this. So I will start directly from the software configuration. I will not see how to install the software because this changes from operating system to operating system. I assume that you already know how to install the software. We have our repositories on our website where we have all the instructions, and it's really easy to install the software. I do not expect that you do this with me for this session, so don't worry about that. So for the software configuration, I will use the nBox user interface. So I connect to my machine, which is running our software, including the nBox, port 9090, and I get the login for this machine. So this is the nBox user interface. We will see tomorrow that we introduced this early this year, and this is based on Cockpit, with some extensions which are plugins actually for configuring our software. So in this specific case, let's see how to configure. Let's come back here to the drawing. First of all, I want to configure the probes here. So I go in the user interface and create a new configuration for nProbe. What I do here, I select the network interface where my management network interface for the host, where the traffic is flowing and where I want to process the traffic. I select flow export to ntopng because I want to export this information to ntopng, and I specify an endpoint where this data will be exported. Now, in this specific case example, ntopng is running on the same box and it's collecting data on port 6666. And I specify an advanced option, which is the agent mode. The agent mode, as I said, allows me to detect also information like the process which is generating traffic and the user. And then we have other advanced options which are already configured for the code. So in this case, I can run the agent here, which is already running, and that's it. So it's really simple. Now let's see how to configure Suricata. In this case, we don't have a plugin for configuring Suricata because it's not our software. We have to configure it using the command line. Again, I don't want to show you all the details of the Suricata configuration and tuning because we will have our friends from Emerging Threats later today that will show this. But in essence, what you do here in order to configure Suricata and export alerts to ntopng is to, okay, first of all, you do something like in the configuration file in Suricata, you specify, for instance, the signatures that you want to use to detect traffic anomalies. Here, I specified inside this file. Let me show you this file. I have this file here where I have all the signatures that Suricata is using to detect anomalous traffic. So as you can see, this file is a full list of signatures, and later today we'll see even how to write those signatures. And after this, I run Suricata. This is a sample command, which is exporting alerts to syslog. And then I have to configure the syslog daemon to export all the syslog logs to ntopng. In order to do this, I create this file where I specify that ntopng is running at this address and listening on this port. So I run Suricata, and on the other side, I will have ntopng. So ntopng, I specify that I want to receive logs from Suricata on this port 9999, which is what we configure here in syslog. I specify that I want to collect flows on port 6666 from our probes. And that's it. Here I also specify what is my local network. in order to detect what are the local hosts in ntopng. And I run ntopng. So I can go into the ntopng user interface, and as you can see, ntopng is running on syslog to collect alerts from Suricata, and on 0q, this is a 0q endpoint where we receive flows with flow information from nProbe. So here, as you can see, we have, this is the new dashboard. We will see this later today and tomorrow. And here we see that we have some traffic flow, with little traffic because it is a machine that we use for development, and today there is no one in the office for here. Then let's see how to configure ntopdisk. ntopdisk can be configured directly into ntopng. So I go into the interface details, traffic recording section, and here I can enable the continuous recording on this interface. I can specify what is the amount of disk space that I want to use for the pickup data. And I can also enable the smart recording. What is a smart recording? In essence, as I said, ntopdisk is recording pickup data. And it's doing this like a security camera. So it's recording, a security camera is recording like the last 24 hours. And the same happens with ntopdisk because the disk space is limited. And at 10 gigabit, we can have up to 4 terabytes of data per hour. So you can imagine that you cannot record everything for weeks. In order to overcome this limitation, we introduce the smart recording. With the smart recording, in essence, we are using some disks as a cache, so to record the last few hours, for instance. And we use an additional storage, additional disks for the smart recording. That means that every time that there is an alert in ntopng, ntopng is sending this alert to this service, the smart recording service, which is moving the pickup data matching this alert to a secondary storage. So we keep here just the data matching security alerts. In this case, the data retention here can be hours, here can be weeks. So we can keep in a storage with the higher data retention, the traffic that really matters. Clear? Okay. Okay. So we configure. We configure all the software now. Now, what we want to do? So we are already analyzing the software. We're already able to, when there is, I don't know, a security issue which is detected by Suricata and ntopng, we're already able to detect that, trigger an alert, and we have the pickup data on disk. But we want to get notified about this alert when it happens, because otherwise it's useless. In order to do this, we can go in ntopng under alerts, notifications, and we can create a notification endpoint. Notification endpoint is a place where we want to send alerts. We have many options in ntopng, so we can send alerts to messaging systems like Slack, Telegram, Mattermost. There are many. We can send to Elasticsearch, we can send an email, syslog, Microsoft Teams. We have many options. We can run a script, we can run a webhook. We have many options. For instance, we can configure Telegram. Here there are instructions to generate a Telegram token. So I already created one. After this, you configure a reciprocate. In the reciprocate, you specify what you want to send to this endpoint, for instance. So let's see this one. So I created this reciprocate where I specified that this is on the Telegram endpoint. And I configured this to receive security alerts on my phone. I specify that I want alerts. And I have two options. I can specify what alerts I want to receive by properties or by alert type. By properties means that I can tell I want to receive alerts which are only critical and up. By category, like, I don't know, intrusion detection, active monitoring, and other advanced options, or I can configure specific alerts, alert types. So in this case, I want to receive just external alerts, which are those coming from Suricata, and another type which is suspicious DNS traffic. So every time there is an alert matching those types, I receive a message on Telegram. Or I can also silence the duplicated alerts. That means that I want to receive just one alert per hour matching those criteria, because I don't want to get tons of alerts on my mobile phone. And again, there are advanced options, like I can configure a set of hosts which are interesting for me. I want to receive alerts only matching those hosts. So at this point, we are ready. The system is ready. And we can go ahead and simulate an attack. So as we said at the beginning of the presentation, we will use this tool, DNS to simulate data exfiltration over DNS. You can find this on GitHub. It's a really simple tool in Python, which is a bunch of lines of code that generates DNS requests with the data encoded into the subdomain. And this is really nice because on the server side, so on the attacker side, you have this Python script running like simulating a web server, DNS server. On the client side, you don't need any special binary. You just need tools which are already present in the machine, like dig, sed, zip, and base64. So in essence, you can use this to exfiltrate data, even injecting a command from a web server. So this is compressing the files, encoding, and sending this DNS request. So this is our testbed. So I have a machine where my network monitoring software is running, and where that I will use to generate, to exfiltrate the data. So where we will run our client, let's say, sending data out of our network. Let's call it compromised host, which is DevLE with this address. This is generating DNS request with our data encoded here to another machine where I'm running the DNS steal software. So those are the commands that we will run. So on the server side, you have this Python script, which is listening on this specific address for DNS request. So this is the attacker machine, let's say. And here we have a command that we can use to send this file, data.txt, using dig, so doing DNS request to our server. So this command is using all the tools for encoding the data. But again, this is just an example, just to show you how this is detected, how it can be analyzed with the software. So what will happen when we run the test, the simulation of the attack, is that this machine will send a DNS request to the data. The packets for this request will go to ntop, that will record the pickup data, and Suricata, that will hopefully detect the attack and send an alert to ntopng. At the same time, the host is running our probe. So traffic information, including the DNS request, will be sent to ntopng, including process and user information. Okay, so let me simulate this attack. So on this side, I will run the server. So this is what you get from, let me remove these sample files. So this is what you get if you download DNST from GitHub. So you can run the server. This is a script that we created after. So where we run just DNST on the IP address of the machine. So we do sudo. So the server is running, and this is on the attacker machine. Now on the internal machine, I will run this command for sending this simple text file to the server. So this text file is the content. It contains just some text in the single file. It contains HTTP. So we run this script with this file. So this generated a DNS request to the server. Now, I received right now a notification on Telegram. Now you cannot see it, but I will show you the slide. And if I'm on front of my ntopng, I can go on the live flows, so to see the electron communications, and see, for instance, filter by DNS, because I received another reporting a DNS filtration. And you can see here that we have a DNS flow with an alert. So let's try to analyze this flow. So again, this is a live flow, because I was in front of my dashboard and I went here just and checked the live flows. But after a few minutes, we will see later today, we look at how flows are managed in ntopng and nProbe. After a few minutes, this flow will expire because this is the active flows. This flow will no longer be active, so will be removed from the active flows. But you can still inspect these in the historical flows. I will show you later on that. So let's analyze this flow. So here we have, of course, the client and destination. So this is the compromised host, and this is the attacker, the DNS server. We have where this flow has been seen, one packet in one direction, one packet in the other direction, so DNS request and DNS response. And we have a few issues detected by ntopng. So we have DNS invalid charters, so there is some charter in the request which is not considered valid. Suspicious DNS traffic detected by ntopng. Invalid DNS query, so this query was strange. And then we have an external alert. This is coming from Suricata. And we can see exactly what it's about. But we have even more information. So look at this. We have the DNS query, first of all, so we have the actual domain that has been requested. Now here we can jump and get the full domain name, which is containing our encoded data for the request. But we also have process and user information. So we see that we have our host, which is that generated this traffic using dig. We have the full process name, so that the binary was on the user being dig. Now in this case, it's a standard binary, but maybe you have a binary of a malware here. We see if this binary is part of some package installed in our system, and we see the user that ran this attack, that has intended the data. Now, what I received right now on my mobile phone is this. So I received an alert, reporting external alert from Suricata, which is detected DNS alert exfiltration possible. The severity is error. So this is likely to be a real data exfiltration, but we are not pretty sure. Then we receive the second alert. This is coming from ntopng itself, which is combining the data from Suricata and the other issues detected by ntopng, like suspicious DNS. So the score here increased because of many issues together. Suricata, suspicious DNS, invalid charters, etc. And the severity is going here and became emergency. So this is getting serious. I have to analyze this issue. We've seen this. Now we've seen the live flow. Because we have been lucky, we were on the PC and we jumped here and we detected that. But we can also go in the Alerts Explorer. This was an alert on a flow. So let's go to flows. And we see here that we have this alert, which is pretty, which has a nice score, an external alert, which is what I received on my mobile phone. So detected DNS alert exfiltration. Here we have all the data, like the domain, the domain name, which is containing the encoded data and other information. And I can jump from here to the historical flows. So here we have all the historical flows in our database, which is ClickHouse, filtered by IP and port from the alert. What we can do, in case we lost the live flow, we can go here and check the information, which is that are coming from the database, which are more or less what you see in the live flow. So again, here we have all the issues, the process, etc. Now, I want also to see what data has been moved out of our network. So in this case, I see that there is a DNS filtration, and I say, okay, let me try to take a look at the pickup. I have the pickup here because I have ntdisk running. So I can click on download pickup. This is running an extraction on the specific time interval of this flow using port IP and port of this flow. So I apply, and this is downloading the pickup. So I can click here and over with Wireshark. So here I have the actual DNS request with raw packets. So here I can see the request. I can now in this case I already have the information about this DNS request in ntopng because ntopng extracts the domain name. But in other cases, maybe you have to go inside the packet to extract additional information. Now I will use this packet to check the request. So I see here that there is this query, which is a strange query. So let me try to copy this the value. And I've seen that this is a DNS request. I want to try to decode this with some tool, which is decoding data encoded by common tools for extracting the data. So I have this DNS decode that can be used to decode DNS request used to extract the data. So I do this generates a file. And this contains information that the user exported to the attacker DNS server. So, in essence, okay, we'll do this. In essence, we have seen how all those tools can be combined together to detect the attack, to analyze the issue, and see even what data exfiltrated my network. And now, again, in this case, we already had the DNS request in ntopng, so we didn't really need ntdisk. But in other cases, you really need to go inside the packet, or even, for instance, Suricata is able, Wireshark is able to replay a call in a voice over IP network communication. So in that case, you cannot do that with ntopng, you need an external tool. Okay, any question?